So today we'll briefly go over the greatest common divisor, this notion. The greatest common divisor of n and m is the largest integer that is divisor for both n and m. So for example, we have two numbers 6 and 9, and we can notice that 6 equals to 2 times 3, 9 equals to 3 times 3. So their common divisor are 3. And so we actually don't have another choice here. So the greatest common divisor here is also 3. And the second example that we notice 13 is a prime number. So since 100 is not a multiple of 13, so their greatest common divisor is just 1. And the third example tells us the greatest common divisor here is 3. So maybe we'll say if we have 6 and 18, now they have the common divisor of 2, 3, and 6. So the greatest common divisor for 6 and 18 will be 6. And just as the second example said, n and m are relatively prime if their greatest common divisor are 1. So this is the formal definition of greatest common divisor. So definition is, so for m and n that belongs to an integer, the common divisor of m and n are those the intersection of divisors of m and divisors of n. And the greatest common divisor is the maxed integer of the set, the common divisor of m and n. So what could we use for the greatest common divisor, and how we're able to compute them? So for computing the greatest common divisor, at first you might think we need to factorize both of the integers, and then to find the common divisors, and then to find the max of them. However, that is not what we usually do, because usually in the cryptography, we have a huge number, and it's very hard for us to factorize them. And so we have a Euclid algorithm. So it's used by this theorem 8. So first we have to prove and understand the theorem 8 in order to get what is the Euclid algorithm. So theorem 8 tells us that the greatest common divisor of n and m equals to the greatest common divisor of n minus m and m. So I have already listed the proof here, and we have to prove in both directions for this equation to hold. So it is mainly algebraic proof. So for today, I will just skip those. And let's jump into the Euclid algorithm. So using the theorem 8, we are able to show that we could just keep finding the number like n minus km until we hit 0. So that means the number with the 0, that one is the greatest common divisor.